Ah, number 37, chapter 10. Rewrite each expression below. In parts B and C, write an equivalent expression without parentheses. Okay, so they want us to get rid of the parentheses as well in part B and C. So let's start with A. So just thinking of the fundamentals here, right? In A, I've got the number 6 in the numerator, and 6 itself is comprised of two factors, 2 and 3. Why that's nice is to notice is because I notice the denominator does have a factor of 3. The numerator also has two factors of x and it has three factors of y. So I could rewrite the numerator as 2 times 3 times 2 factors of x and then times 3 factors of y. And in my denominator, I have a factor of 3, I have a single factor of x, and I have a single factor of y. So when I look at this like this, and it's not necessary that I expand it out, but when I look at it like this, it's clear that there are common factors, right? So, or we could call them giant ones. This equals the number 1, right? 3 divided by 3 is the number 1. X over x is the number 1. This y divided by this y is the number 1. So because those are each equal to 1, and again, there's no terms here, these are all just factors, right? I can rewrite this in its simplest form, or in a simplified form, as I've got a 2, a single factor of x, and two factors of y. So I'd write 2x y squared. All right, let's go over to b. Now, b, there is this negative value, right? There's an opposite m. So if I was going to write this out, there are three things that are being multiplied. There is a negative mn, well, three things. I'm just looking at the fact that there are three sets of factors that look exactly like this. There's another negative mn, and there's another negative m. Oops, don't close it. There's an n in there also, n. So part of this is that I've got n times n times n. Okay, what's that? That n times n times n, that's n to the third. And I've also got this negative m, negative m, negative m. Now, I don't even want to think about whether or not m is positive or negative. So I think what I'm going to do is choose to think of this as it's a negative 1 times mn. So that's certainly the same, right? So the opposite of m times n is the same thing as negative 1 times mn. And if I write that out 3 times, there's my negative 1 mn and my negative 1 mn. What I have here in terms of m is I have three factors of m, and I have three factors of n, so that would be n to the third. And I also have three factors of negative 1. Now this is just a number. I can evaluate what this is, right? This is negative 1 times negative 1 times negative 1. When I multiply negative 1 times negative 1, I get a positive 1. And when I multiply that by negative 1, right, this becomes negative 1. So there's a negative 1 sitting in front of this. And probably what I'll do is I'll go ahead and say, well, that's just what? It's the opposite of whatever this m cubed n cubed is. Now, notationally, right, it's important to realize that we are cubing m, we are cubing n, and then we're taking the opposite of that. Okay, very different than this. Well, or is it? Or is it? Because that would still give me the negative, right? I guess it would be different if I was squaring it. But I just want you to realize that there is fundamentally a difference between the opposite of x squared and the opposite of x getting squared. And I think that's the point I'm trying to make. So there's a difference between those two. But this is our answer. It's the opposite of m cubed n to the third. All right, so now let's go ahead and take a look at C. It says, again, we're supposed to write this without the parentheses like we did in B. For this, I understand that if I multiplied this by m n to the positive third over m n to the positive third, by introducing this giant 1, mn cubed over mn cubed, I destroy this particular negative exponent. So what I'm looking at now in my numerator, mn raised to the negative third times mn to the third is mn to the 0. Anything to the 0 power, pretty much anything to the 0 power, anything to the 0 power is 1. So I've got a 1 in my numerator, and in my denominator I have mn cubed, like this in parentheses. Don't forget those. There are still parentheses in my answer, so I could expand this and look at it. It's mn, mn, and mn, right? Which is what? It's 1 over m to the third n to the third. So this is my answer for part C. And then finally we've got part D. Part D looked like it was a division problem with scientific notation. So I want to first of all just look at this. It doesn't say that I have to write my answer in scientific notation, but I'm just wondering, what's 3.2 divided by 8? It's 0.4. So I could do that. 3.2 divided by 0.8 is that pen too thick? Let's see. I'm going to go a little bit thinner on this pen. So if I go 3.2 divided, that is going to be 0.4. And then I still have this numerator with 10 to the negative second and a denominator with 10 to the third power. But I can neutralize this negative exponent in my numerator by multiplying by 10 squared over 10 squared. Again, these two things, right, 10 to the negative second times 10 to the second is equal to 10 to the 0, which is equal to 1. So I end up with a 1 in that numerator, and I've got 10 to the 5th power below, and I've got this 0.4 here times that. Now, there's lots of ways I can express that. I could put the 0.4 in the top, and I could say over 10 to the 5th. That's equivalent. I could also write this as a 0.4 and make it a negative exponent times 10. This would be 10 to the negative 5th. Right? I could do that. If I wanted to make this in scientific notation, I know that I need to I can't have a 0.4 if it's in scientific notation, so it would have to be 4. But in order to make that the number 4, that would be well, in order to make the number 4 back to 0.4, I would have to multiply that by a 10 to the negative 1, and then times 10 to the negative 5th. So let's explain this. So this 0.4 right here is the same thing as 4 times 10 to the negative 1st power. So those things I've underlined in blue are equivalent to each other. So it's totally okay for me to replace 0.4 with something that is equivalent to 0.4. So by writing it this way, you can see now my number, right, is 4.0. And then my exponent is 10 to the negative 6th power. So if I wanted my answer in scientific notation, that would be the equivalent, right? 4.0 times 10 to the negative 6th. So all of these things that I've written for part D are equivalent to each other. If the intent, because I look at this problem, I say, oh, it's the numerator and the denominator are clearly in scientific notation. So if I was to do this problem and write my answer in scientific notation, I would write 4.0 times 10 to the negative 6th.